Hello my dear friends, welcome to the class of engineering mechanics. How are you? Everything is fine? So till now we have seen CO1 where we covered about forces, different types of forces, their application effects. Then we have done CO2, there we have seen trusses, there are different methods to solve the problem of truss, correct? Now today we will talk or discuss about CO3 that contains about friction and moment of inertia. What is friction and what is moment of inertia? Okay, so this is one of the best example. When you are wearing shoes and moving, what you are doing actually? What we are doing, we are pushing to the earth. Push from grass on sole of shoe, push from sole of shoe on grass. One is action, another is reaction. You are pushing to the grass and then in return you are getting reaction from grass to your shoes. One is action, one is reaction. Now because of this there will be friction. Now what is friction? Friction is nothing but it is a force that opposes motion between two surfaces which are in contact or which are touching each other. For example, here there are two surfaces. What are those two surfaces? Here there are two bodies, one is violet color, one is green color, correct? They are moving. How? When you are applying force on upper block, upper body, it is trying to move forward, correct? So there is contact surface in between. Here you can say in the red color arrow, here there is a contact between these two bodies, correct? So because block is moving this direction, because we are applying force this direction, so friction will generate in opposite direction. What it will do, it will try to oppose the motion of the block. Okay, so friction is nothing but it is a kind of force which opposes the motion between two surfaces touching each other. There should be contact between the surfaces, that is important. Okay, now cause of friction, it can be due to irregularities, up and downs, rough surfaces, correct? And surfaces are not smooth. Generally surfaces are not smooth in actual. And there are some ideal conditions which you used to take for analysis, but actually there is nothing smooth. There will be something little bit irregularity will be there. Okay, now in this example you can see N, this is nothing but normal force. Okay, now this is the contacting area represented by ANOM. When you enlarge this using some lens or something, then you will see here it is looking very smooth, correct? But when you enlarge this, then you will find there are different irregularities. This is true contact area, this is nominal. Okay, so there are a lot of irregularities which will try to generate friction. Now friction is a friend or foe, means it is good or bad, that you have to decide. When you are walking it is good, when you are rubbing it is good, when you are climbing it is good, correct? So you have to decide those things. Here car is moving due to friction. So types of friction, there is static friction and kinetic. Static means at rest, kinetic means moving. Now under kinetic friction again, rolling friction, sliding friction, fluid friction. Rolling means something is rolling from up to down, correct? Then there is rolling friction. There are skates, rollers, they will generate rolling friction. Sliding friction means when you slide from somewhere. Sliders are there in zoos, in gardens, parks, correct? So when you slide, then there is sliding friction. Then fluid friction. In fluid also, there are different layers of fluids, and in between there will be friction. Okay, so what are these things we will see later on. Now there is law of friction, law of Coulomb friction. It is nothing but force of friction is proportional to normal reaction. There is one force, there is one normal reaction. both are proportional. When you remove the proportionality constant, you will get a factor known as mu. This symbol is known as mu. It is a Greek letter mu. This is known as coefficient of friction. Okay, so you got F equals to mu n. So mu will be nothing but ratio of F by n, means ratio of limiting friction force to the normal reaction. This will give you coefficient of friction. Generally it is less than 1. It is 0 to, it is between 0 to 1 only. Okay. Now different zones of friction. Zone of static friction, zone of kinetic friction. The limit or the zone where it changes, there is known as impending motion. Means till impending motion, the thing is in static. How much friction, no issue, how much force, no issue, body is in static. So you represent by mu s, coefficient of static friction, mu s. After this limit, the body will start to move, a motion will start. That is known as impending motion. This is small area, you can see the value of friction decreased, correct? Then again the body will start moving, so you will get mu k, coefficient of kinetic friction. Okay. Now what is limiting friction? It is nothing but maximum value of friction experienced by body. Maximum value of frictional force experienced by body. After that the body will start moving. Now angle of friction. It is nothing but the angle made by resultant with the normal reaction. Phi, here you can see phi is nothing but angle of friction between resultant and normal direction. So you will calculate here tangent of phi, known as tan phi, is nothing but f by n, and f is nothing but mu into n. So it will cancel out, simplify, you will get tan phi equals to mu. So coefficient of friction is equal to tangent of angle of friction, phi. So phi you will get as a tan inverse of mu. All these things are important during mathematical calculations. Now angle of repose. That was angle of friction, now this is angle of repose. What is angle of repose? It is angle of inclined plane made with the horizontal. When? During the motion. During the motion. The angle between inclined plane and the horizontal during the condition of motion. This is known as angle of repose. Now rolling friction. What is rolling friction? It occurs between surfaces in which one of surface will roll. You can see here example of painting. When you are doing painting in the wall, here you can see there is a roller which you are rolling, correct na? So this will try to generate a rolling friction on the wall, because of which you can apply the paint easily on the wall. This is important. Okay, so till now you have seen what is friction, what is coefficient of friction, and now you are seeing what is rolling friction, what are the rollers here. Now another is sliding friction. When you are writing through chalk or pen, correct, then it is known as sliding friction, because you are sliding one surface on another surface. Next, different types of problems. See, here there are two bodies which are connected. One is represented by W1, another is represented by W2. Both are on inclined surface. The inclined surface is making angle alpha with the horizontal. Such kind of problem we have to solve. Next, wedge friction. Wedge. What is wedge? It is a triangular object. One thing on another thing. One of the best example here is these logs, wooden logs. These are also wedges. So wedges are used as shown here to split the trunks. Here you can see log hand, and hand is pressing something. This is triangular shape something, V shape. This is wedge. You can see a X by which you will break the wood. That X shape of X is how. So that is also a kind of wedge. When you are moving, you are stopping a car on any slope. On the back side of the tire, you will put something to block the motion. It is also treated as wedge. Okay. Now, ladder friction. When you are climbing, for example, here a monkey is climbing, or another example, man is climbing. So this is another example of friction, which is ladder friction. Okay. So like this, there are different types of example, different frictions. Now important thing is centroid and center of gravity. There are two terms, centroid, center of gravity. Both are different. How? Let us see. First, centroid. It is a point about which entire area is assumed to concentrate. Where area is assumed to concentrate. But in center of gravity, it is a point where entire weight of body is concentrated. Correct? One is area, one is weight. Next, centroid is related to 2D figures. Plane figures means 2D figures. Whereas center of gravity, center of mass is related to body having gravity, means 3D. A body having gravity. Correct? So these are some differences. Now you should be able to differentiate between centroid and center of gravity. Centroid is a point about which area is assumed to concentrate. But gravity means, center of gravity means entire weight is assumed to concentrate. Centroid is 2D figures, center of gravity is 3D figure. These are some examples. And where is the CG? CG is nothing but center of gravity. Okay. A person is balancing. How he is able to balance? By managing the center of gravity. Formula 1 cars are there. You have seen racing of car. Correct na? They are moving with very much fast speed. And they will not turn around, means they will not topple. How? Because of center of gravity. Okay. Stable boat, unstable boat. Stable boat means center of gravity is correct. Unstable means center of gravity is some problem is there. Okay. Now how to find center of gravity? These are some formulas. In x-axis, y-axis, z-axis, how to find. Okay. X is coordinate, dm is nothing but a small amount of mass. dm is a small amount of mass. Okay. So this will be useful afterwards when you are solving the problems during class. So this is about mass, center of gravity. Now this is center of volume or centroid. Here you talk about volume. Okay. There was mass, here is volume. In the same way, center of area, here is area. Okay. Now centroid of some regular or plane figures. Axis symmetry. This body is symmetric about x-axis as well as y-axis, the I section. You can see here. O section, that is also they will be symmetric. Correct. Now rectangular area. Here how to find area of rectangle, you know, breathe into height. Correct. How to find centroid? Here in this figure, h is height, b is width, and here it's the center C. This is nothing but centroid. Now how to find value of centroid? So for rectangle, half of height will give you value of yc, means distance of centroid in vertical direction. Similarly, in horizontal direction we will get xc, half of width b. Like this, there are some other examples: triangle, semicircular, okay, quadrant. All these things we will discuss in brief afterwards with the class. Just now I am giving you a small glimpse. Okay. Now these are some composite figures. Now till now there were only single figures. For example, only quadrant, only semicircle, only triangle. Correct. But now we will talk about composite, made of many things. For example, here first one, cylinder, outside one, another side another one is cylinder, circle. So these are some examples. These are more examples. Now this one, upside bigger rectangle, downside small rectangle but width is more, in between thin one, vertical. Left side you can see there is a blue color triangle, green color rectangle, and then here circle. So these are some examples of composite figures. So we are going to find how to get centroid for such difficult and composite figures. For simple figures already they are predefined centroid values, but for complex we have to find. Okay, these are some examples. Now coming to moment of inertia. Till now we talk about centroid, center of gravity. Now moment of inertia. What is definition of moment of inertia for any area? Centroid for an area is determined by first moment of an area about an axis. How to find it? Second moment of an area is referred as moment of inertia. How to find moment? I told you, force into distance. Second moment means 2 times you will take distance, means distance is square. Now here it is moment of area. There was force, here it is area, but the format is same thing, distance and whatever you require, that thing. Okay, so second moment of area is referred as moment of inertia. You should know this thing. Now coming to moment of inertia, how to get it? As I told you, second moment of area is known as moment of inertia. So here you can see dA is small area, distance is from x-axis, distance of dA is y, from y-axis distance of dA is x. So how to get moment of inertia about x-axis means Ix, area into y square. If you will take area into y, then it is first moment of area. I want second moment of area to get the moment of inertia. Second moment of area means area into distance square. Area into distance square. Here distance is y. So area into dA into y square will give you Ix. Similarly, dA into x square will give you Iy. But we have to integrate it because there is dA, differentiation of A. We have to remove this differentiation symbol, so we will integrate over complete area. Is it clear? Now this is one theorem, perpendicular axis theorem. When the axes are perpendicular, then how to find? For example, there is x, y and z axis. You know moment of inertia about x axis, you know about y axis. You have to find about z axis. So Iz will be equals to Ix plus Iy. Summation of Ix and Iy will give you moment of inertia of third axis. It is also known as polar moment of inertia. Next, parallel axis theorem. You have moment of inertia about one axis. You are drawing a parallel axis about that particular axis, and you have to find moment of inertia about that. For example, x bar is one axis, x is another axis. You know about one, you have to find about another one. How to get it? So here the formula are there. For different structures there are different formulas. So all these things will be given to you and you will learn this. Okay, these are another examples. Okay, so friends, this is all about moment of inertia and friction. I hope you understood. If any doubt, you can ask me. Thank you.